Yeah, good morning to all of you. In this lecture, I am going to discuss the concept of Lagrangian equation of motion. So, in this lecture, if we have for a given Lagrangian, if we have a profile of Lagrangian, so how to obtain the expression of equation of motion? In previous lecture, we have already discussed the basics of classical mechanics, concept of generalized coordinate, constraints, degree of freedom, and then what is Lagrangian is a function, and Lagrangian is a function of generalized coordinate, generalized velocity and time. And for a given Lagrangian, if we have a profile of Lagrangian, how to find out the generalized momenta, and how to check the cyclic coordinate. So we have already in previous lecture we have already discussed the concept of cyclic coordinate in detail, that the cyclic coordinate, if there is a cyclic coordinate for any dynamical system, which means corresponding momenta is conserved, and the force, there is no force acting in that direction. So we have already discussed in this lecture, or in another word we can say that the objective of this lecture is to understand the concept of Lagrangian equation of motion for a given profile of Lagrangian. So we have example in which the Lagrangian of a system in cylindrical coordinate system is given as 1 by 2 m r dot square r square theta dot square plus z dot square minus mgz. So we have profile of Lagrangian in cylindrical coordinates. So this Lagrangian is basically T minus V. So this is kinetic energy and this is potential energy. So how to obtain the Lagrangian equation of motion? So the Lagrangian equation of motion, so this is the solution. L equation of motion is simply d by dt del L upon del qk dot minus del L upon del qk. This is for conservative system, and where qk is generalized coordinates. So in this case, what is our job? Our first task is to identify the number of generalized coordinates in this Lagrangian expression. So corresponding to this Lagrangian expression, we can see that there are three different generalized coordinates. So correspondingly, we have three different Lagrangian equation of motion. So we have r generalized coordinate. Our Lagrangian is in r, theta and z. So there are three different kinds of generalized coordinates. So correspondingly, we have three different equation of motion. So if we talk about r coordinate, so for r generalized coordinate, Lagrangian equation of motion is simply d by dt of del L upon del r dot minus del L by del r, which is 0. So this is corresponding to r. So we will simply evaluate the value of del L by del r and del L by del r dot, which means differentiating our Lagrangian expression with respect partially with respect to r and partially with respect to r dot, and then putting the value of these two entity in this equation and simplify the expression. The simplified form will give us the Lagrangian equation of motion corresponding to this r generalized coordinate. This is our this is our objective. So let us evaluate what is del by del r. Del by del r means differentiating L partially with respect to r. So del by del r 1 by 2 m r dot square theta dot square plus z dot square minus mgz. Now differentiating partially with respect to r, so this will give 0, this will give something, this will 0, this will 0. So what we have simply del L by del R is M R theta dot square, M R theta dot square. Now similarly differentiating this L partially with respect to R dot, generalized velocity. So del by del R dot, now L is simply M R dot square R square theta dot square plus Z dot square minus mg z. Again differentiating partially with respect to R dot, so we have only one term in Lagrangian, that is R dot square. So if you will differentiate, it will give us twice of R dot and rest will be 0. So what we have simply, and 2 will cancel out, and we have simply M R dot. So now putting the value of del L by del R dot, del L by del R dot in, so let me, this is equation 1, this is equation 2, and this is equation 3. Now from equation 1, 2 and from equation 1, 2 and 3 we have what we have. Now putting the value of del L by del R dot, which is simply M R dot minus del L by del R, which is M R theta dot square. So now differentiating with respect to R dot, so this will give double dot. So this will dr dot by dt M R theta dot square equal to 0, or this can be written as M R double dot. So M R theta dot square equal to 0. So this is second order differential equation. This is second order differential. What is your R dot is simply dr by r del r by, for one variable it is dr by dt. Theta dot is d theta by dt, and r double dot is dr dot by dt or d2r by dt square. So this is partial, but if it is function of only one variable, then it will converted into total differential. So there is no difference between partial and total if our r is only function of one variable. So this is second order differential equation. So this is Lagrangian equation of motion corresponding to r generalized coordinate. Let me tell you, this is equation number 4. Now we have second for theta generalized coordinate. If we have, because we have three independent, so corresponding Lagrangian equation of motion is d by dt of del L upon del theta dot minus del L upon del theta. So what is del L upon del theta? Del L by del theta is simply, because there is no theta expression in our Lagrangian, so del L by del theta is simply 0. What about del L by del theta dot? Which is, because we have theta dot expression, there is one term corresponding to this Lagrangian. So we have this profile of Lagrangian in which we have one theta dot term. So if we will differentiate partially with respect to theta dot, so this will give twice of theta and rest will be 0. So twice of theta dot r square, and this 2 will cancel out. So what we have, del L upon del theta dot is simply m r square theta dot. Now again putting the value of del L upon del theta, del L upon del theta dot and del L upon del theta in this equation 5. So putting the value, value of del L by del theta and del L by del theta dot in equation 5. What we have? We have dy dt of mr square theta dot minus 0, which implies that mr square theta dot is equal to constant. So this is another equation of motion, means, and this is angular momentum. This is angular momentum which is constant of motion. So there is no force, there is no torque acting in this direction, and we can say that we have already discussed the concept of cyclic coordinate, that if our del L upon del qk is 0, if our del L upon del, so qk is cyclic, here del L upon del theta is 0, so theta is cyclic. This Lagrangian have cyclic coordinate in theta, so it means corresponding p theta means angular momentum is conserved, which means there is no torque acting in this direction, because rate of change of linear momentum is force and rate of change of angular momentum is torque. So torque is, there is no torque acting corresponding to theta coordinates. Now next we have, third we have for z generalized coordinate. So Lagrangian equation of motion for z coordinate or z generalized coordinate, which is dy dt of del L upon del z dot minus del L upon del z equal to 0, which implies that del L by del, what is del L by del z? Which is del L by del z. So there is one term in our Lagrangian which contains z. So for differentiating partially with respect to z, so we have minus this whole kinetic energy term is 0, and we have only del L by del z corresponding to this potential mgz, which is minus mg. So del L by del z is simply minus mg. And what is del L by del z dot? Again differentiating this Lagrangian partially with respect to z dot. So this will give twice z dot. So 2 will cancel out, we have mz dot. So now putting the value of, again putting the value of del L upon del z and del L upon del z dot from here to this equation. So what we have, dy by dt of mz dot minus mg equal to 0. So this minus minus becomes plus, and we have final profile of equation of motion, which is mz double dot minus plus mg equal to 0, or this may be written as mm will cancel out, z double dot plus g equal to 0. So we have three different equation of motion. This is equation number 6. So this equation number z double dot is, again z double dot is simply d2z by dt square. So again this is second order differential equation. So corresponding to three different generalized coordinate, we have three different equation of motion. So this is very important conclusion corresponding to this example, that our degree of freedom, if someone asks what is the degree of freedom of this system, if we have a profile, if we have profile of Lagrangian, if we have a final profile of Lagrangian, and someone asks what is the degree of freedom corresponding to this Lagrangian, so we have well known tool, we have well known definition, which is number of generalized coordinate is equal to the number of degree of freedom. So in this case there are three generalized coordinate, r, theta and z. So degree of freedom in this system is, degree of freedom of this Lagrangian is 3, and number of degree of freedom is equal to number of generalized coordinate is equal to the number of Lagrangian equation of motion. So there are three Lagrangian equation of motion because we have three different generalized coordinates. So corresponding to three different generalized coordinates, we have three different equation of motion, we have three degree of freedom. So in this example, there are lot of objective questions. We can formulate lot of objective question from this long answer questions. That the question number 1 is, we have a profile of Lagrangian. So from this Lagrangian, we can directly find out the degree of freedom by using the concept that how many number of generalized coordinates. So there is one objective questions, that what is the degree of freedom of this Lagrangian. So directly, without evaluating, without using 3n minus k formula, you can directly take that there are three generalized coordinate, and we know number of generalized coordinate is equal to the number of degree of freedom. So there are three degree of freedom. And how many Lagrangian equation of motion? Because we have three generalized coordinates, so corresponding there are three Lagrange equation of motions. So it's all about, so you can formulate n number of questions from a long answer question. We can formulate n number of objective questions. So it's up to you, and it's all about this question, that for a given Lagrangian, how to find out this concept, how to analyze, how to understand the concept of cyclic coordinate, how to understand the concept of generalized momenta, how to understand the concept of degree of freedom, how to analyze how to understand the concept of Lagrange equation of motions. So thank you.